Hey everyone, how are you doing? Eyal here, thank you for joining my stream. I'm going to be continuing from the previous stream that I've done. Just make sure that my audio is set up correctly. With the cheesy AI generated but royalty-free music. Yeah, so as you've been following from the previous stream, hopefully, I'm working on a little rhythm game. Kinda gonna be inspired probably by DDR, Dance Dance Revolution, but might have some really cool features that we'll add. The idea is that this is gonna be a game based on sequencing and timing of when you play things. So yeah, so what I did in the previous stream. In the previous stream, I have just worked on creating like a lot of like basic fundamentals. I was setting up a few JUCE modules. One, probably you can see the file names in here. One of them was called EA Audio Common. The other is EA Common. EA Audio Common kind of depends on EA Common. They're all JUCE modules that are meant to like abstract patterns. We're going to run into that a lot because I'm hoping that one of the things going to come out of this project is that I will have this publicly available library of things I always do that I can reference to in public projects. I have those, usually in every project that I work on. I write a big library of usable things, but those are usually in like proprietary code bases. They might get tangled up with business requirements. And here I'm just putting it all open source. So this is kind of good. Hopefully this will bring some useful information and tips for people who are into the process of coding in C++ or in JUCE. Yeah, so what we've done the previous time is, let me switch up this in here a little bit. Good. So what we've done the previous time, I'm thinking maybe I'll move myself to the other side. Maybe this is going to look better. Who knows? Maybe the left side is better. Hopefully it's not going to cover too many things. It's here. Okay. Sorry for the little setup moment here. Okay, so here's the idea. Let's run through what I've done last time. First of all, one of the things I'll kind of reiterate, we've done all this stuff. We kind of structured it as a plugin, and I'm actually going to test it as a plugin for different reasons, even though it's probably going to be a standalone app. There is actually something in the plugin process flow that is going to help me do a lot of musical things, make sure that my sequencing is correct, my timing handling is correct, and it's also going to use a lot of pre-built mechanism in JUCE, like for example when I'm running you see I have just a black screen here because I didn't do any UI, but JUCE kind of gives it to you by default, something like audio settings with buffer sizes and things that are actually needed to test audio properly, which is going to be a key part of this game. Audio, MIDI, etc. Anyway, so what I have right now, hopefully it's going to be loud enough, is that I made a very small synth that plays white noise with an envelope. I don't know if you can see my hand. It doesn't matter where I hit the keyboard. I can just hit it somewhere. It's going to play beautiful white noise, polyphonic white noise too. Like I can start in another voice. I have 3 voices. Remove them, get softer. Remove one, get softer. Remove one, it stops. I just did the white noise thing for testing, and what we're actually going to do probably just now is I'm going to transform the synth so that it's slightly more useful. It could play notes, so I'll switch it to using something like a sine wave or a square wave, and we're going to work with that. As usual, I'll just say, first of all, if you're watching this on my YouTube or something, I'm streaming this on Twitch, Facebook, blah, blah, blah. If you're watching this on YouTube or something, you can subscribe, or Twitch subscribe. That will be fun. If not, you can just post comments. I can see the comments from the different streams, and I'll bring them on screen so that people from the other areas of streaming can watch this. Good. So let's go back to C++ land. I want to get in rhythm. Hopefully, audio is okay. Hopefully, everyone can hear me fine. And let's get into it. So I'm just trying to kind of deal with my own listening level so that I don't overwhelm myself with my own voice. Hope that's better. Maybe that better, a little better. Okay, all right. So what we're doing now is that I've abstracted this thing called the basic synth. It's basically just a template that triggers a voice. The voice already has a few things that I've set up, like the buffers. It's actually not that clean. I need some amount of work to make it more like I like, but the thing just has the ADSR and the white noise. So I'm going to, first of all, create like a really simple oscillator so it can play more musical notes. And perhaps I'll even write a generic oscillator. That might be fun. Yes, I like that. Because basically, what the oscillator needs to do is it needs to do two things. It needs to follow the phase of the oscillator, and then it needs to, according to pitch, which is basically the phase, it needs to return the position of a sample, kind of maybe interpolates over a wavetable or something. So let's do that. I should have some code that does the math of it somewhere. But I don't want to work too much on writing the math. I'm just going to use very, very simple math here. So let's see, how do I do that? Okay, so great, I like that. So let's see, how am I calling this thing? Stirrers, blah, blah, blah. So the way I usually like to do things is that there's a template that allows you to bring in different oscillator types like saw, sine, square, etc. And then there's just a way to call it with phase. So it basically looks like this. Like the basic function looks something like float, get y, float x, and this is the interface for a synth oscillator basically. So that when we call it, we're going to give it a bunch of axes. If we're just filling the wavetable, we can call it up front, or if we call it in real time, we can use the exact same thing per sample. And then this, because it's a template, we can it will be a template pretty soon. We can specialize it for different types of oscillators in a really cool way. So for example, this is my so good. I might start with the a saw oscillator, because a saw basically means that I'm going to get something between 0 and 1 here on the x-axis. That's phase. You can call it phase, right? So what this, but I'll just call it x because it just makes more sense to me. And then this is 0 to 1, this needs to return a value between -1 and 1. So what this is going to do with a saw oscillator is do something very simple. It's going to use JUCE JMap. This needs to be no except, by the way. JUCE JMap of x to between -1 and 1. Because it will just be like a straight up saw. There's no element of pitch here. This is just like the shape of the thing. And then what I need to do is I need to create something that changes the phase, calls the phase based on the pitch, and then calls this function. So for example, I would need something like a struct oscillator. I'm going to put this in here before I abstract this, just so that it's kind of it's static. That's fine. And then eventually, I have something like a process function that takes float data and num symbols. That's really what happens. No except. That's the interface of this, and it's going to fill the data with this. But it also probably needs something like the pitch, because this also moves the phase. So this needs to be like float pitch in hertz. We might in the future actually make this float pitch so that we'll have modulated pitch. That's also another way to look at this problem. Okay, and then I need to have this little bit of math here, which I should have somewhere around here. How do I use that thing? Let's see. Oscillator. Good. So the phase element of this it's going to be something like a float phase, and I'm also going to have something called a float phase delta, which is how much we're increasing the pitch in every cycle. This gets calculated only when the pitch changes, basically. The actual calculation of the delta needs to happen here according to pitch here. So basically, this is what the thing is. This is what the calculation looks like. So I can do something like this delta is I think it's something like JUCE. What is this called? Math constants float 2 pi times, so this is actually the frec hertz, or the float, I'm going to cast it to float, and divided by the sample rate. Yeah, float, sorry. That's basically the basic function that this needs to do. Once we do that, we can go over the number of samples. This probably should be a separate process altogether. So something like int sample 0, sample, sample. And for each of those samples, we can do something like data sample equals get y. Oh, sorry. I need to move the phase. So the actual phase is increased by the phase delta. Then I fmod it. Fmod of phase and 1. I can probably do the same operation, so it's going to be something like equals fmod of phase plus phase delta, because I need to modulo that with 1. So that's really the advancement of phase thing, and then I'm just going to calculate this by get y with the phase. That's really the basics of running this. And I think this should work and give me a saw. It might be a very loud saw, by the way, so I might need to just apply some gain on it. And it's single channel, so I'm just going to write a helper here that's going to do this multi-channel. So void process. Instead of this, it's going to take a buffer, and it's going to take these two things, except, and what it's going to do, it's going to process the on buffer get right pointer, the first channel, frec hertz SAR. Also, it's going to do the full get num samples, but then it's going to do buffers copy. I might not have it included here. Let's move it to the CPP file. So this is going to be buffers copy to all channels buffer. So this is a helper function I have to duplicate to however many channels I have. So I don't need to process multi-channel oscillators. If I wanted to, I could run separate instances of this with different pitches, for example, which I might do if I have like a unison or a multi-oscillator situation. But that's hopefully is basically the idea before we start to abstract it to something more usable. So I'm going to start by doing, instead of, I'll just replace this white noise with oscillator. So let's see. So let's not call it white noise. Let's call it OSC. It's going to process with buffer the pitch. We actually know the pitch in here, so we should do something like here. We know that frequency in hertz. The sample rate is something that we probably do. We know that. Get sample rate. Yes, we do know that. So it's a double, so we can just cast it to a float for now. Don't bother me, I am totally fine with this cast. We're going to apply for this. Hopefully this gain is fine, but this is really the idea. The one last thing we need for the oscillator is we need to reset, because we want to start from the beginning of the phase. So we need a reset function that we call whenever a note comes in. So no except, this is going to be phase equals 0. Again, not perfect API, but the general flow of this. So, we did this so that when we have a note started, we can go to the oscillator and reset it. We don't have to, by the way, reset the oscillator, but might be a good way to do this. So let's see what we got. Let's see if we got something close to an oscillator, or have I done something horrible? Okay. I do have a synth in here. Sounds pretty horrible, but we will find out why in a second. But I do have a synth in here. First of all, let me start just so that I hear correctly what I've done. Let me change these default parameters on this voice, so the ADSR parameters. So set parameter something. So ADSR. Auto param something's JUCE ADSR parameters. Params dot attack equals really something short. Params dot decay. Is decay here in seconds? I forget. Yeah, it's all seconds. So I basically want the decay to be infinite. Can I do that? Or is it always going to be? It's always going to fall at a certain point. Let's say I give it like 100. I don't know what's going to happen if I do that. Params dot sustain. Sustain is the level, so I think it needs to be 1. And release would be in just like super short, just so we don't get an attack. I don't know what it should be, something like that. So I'm just setting fixed parameters here so I can clearly hear my beautiful thing. It basically works. Let's switch to like a short, smaller buffer. Let's switch to another sample rate and see if that works. Let's switch to like 88. Great. So I have a synth. It plays a saw wave. I am happy about this. So this is pretty good. Let's, now that we know about this thing, let's abstract it a little bit better, because we would need to make this slightly more coherent. So I think what I'll do is I'll have something like the, do I need the, yeah, because basically I need something like a phaser here. Extract phasor. The phasor would need to basically do this whole delta stuff. Basically, we need to hold this everything here, and then going to do something like float advance, take the hertz. Yeah, because this needs basically two things. It needs to set the pitch, because we don't have to calculate this every block. We need to calculate this only once the pitch changes. So it's going to be something like set pitch. This is going to take these two things. It's going to do this calculation here, and then it's going to look like a get next phase, and that is going to do this calculation and return the phase. So we'll accept. So that is basically our phasor. And reset. Void reset. Accept. Phase equals 0. I can probably make this a class. Nobody needs to touch these variables. And I'm actually doing this because it's actually likely that in the future I will make the phaser its own thing, like make a phaser where it's gonna write to a buffer, and I'm gonna pass this buffer to a bunch of different things. Like I might not need to make it so involved inside of the synth. It's a good reusable element even without the actual sound. So this is our basic phasor, and here I can just have a phasor phasor. Process here is just going to do phasor set pitch frequency SR. This will be phasor get mix phase. So this really is all that it does. Reset, if I want to call this, just calls phasor.reset. And we're also going to abstract this even more because, like I said, I don't want to have just saw here. I want to have a few different versions. But I don't want to put like something like a virtual function in here. This is actually won't be good for me because this loop, if it's going to call something like a virtual function, it's going to be extremely slow. It's not going to be inline. It's not going to be optimized. I don't want to do that, but I do want to have the option to not rewrite this for every single oscillator. Let's move this to the other one, and then I can instead of doing get Y, which is probably old, this is going to be private because nobody needs to touch that part of it. This is an internal oscillator function. What I can do now is I can make this whole thing be like be a template basically, and this template only needs to do this. So how am I going to do this? I can let me move this to another file because to be like too involved with too many things. It's possible that some of the stuff needs to be in double for slightly more accuracy, so we can definitely discuss that as an option. Like it would definitely make it slightly more accurate and less jittery. How's everyone doing, by the way? Hopefully people are watching this. It's kind of early here, but hopefully not too bad in some other places in the world. Yeah, where's my module? Let's call this thing an oscillator. I'll remove. I'll take these back here. This class and the phasor class in here. Let's pragma once, namespace CA audio. Let's include buffers. So these are basically the two classes. Now, as we said, this currently does this, but what I probably want to do is something like this, like templates OSC type. Type me OSC type, and then the OSC type here is going to do something like this. For now, I'm not going to support stateful oscillators for now, but in the future I probably could. You know what? Maybe I should support stateful ones just because I also have the option of the white noise, so which probably should be included in here as well. So so that means I should need this as a member. Type my OSC or generator. I can call it generator. And that means instead of doing get y directly, I'm just going to do generator get y. This would not know how this is implemented, but I will soon. Just now, so now I can create something like struct saw. This is like a namespace generators. So this would be. So it would just need to be like a simple struct that has this member function. Yeah, so that's what the saw works. Let's do. Let's write a few other ones. Let's write sign. So sign. Before that, let's do a reverse saw. That's gonna be fun. That's gonna be the simplest one. Struct reverse saw. That would be pretty useful sometimes. So it's the same function. Make it static. I can make it static. And this would just return 1 minus x. So opposite, and then do the translation, the scaling. Let's do sign. So the sign function is basically something like this. It's something like a sign and then static float get y, and it should be something like this times the phase. This is basically the function that it does. But then I'm just trying to think, if I do this, do I also need to do that? No, I think I don't need to do this. I think this needs to be this, right? Sin x. I think this is already right. Am I correct or not? Because if I use this for the phasor, for the delta stuff, I'm not trying this again here. I think this is already okay. This is I just need to do sin x. So this should be the sine wave, I think, because I'm fixing that calculation later. And then a square wave. Square wave would be something like sine I can basically say something like you can first make the sine function. Sin func equals the result. And then if func is greater than -5, make it 1. And otherwise return 0. So that should make a square wave basically. So these are a few ones, and then let's also add our white noise that I've had before. White noise is going to be one is going to be stateful. It's going to have the random object here, and then this function is just going to completely ignore the phase and put in there random, do some return random next float, but it needs to be J-mapped. JUCE J-mapped from -1 to 1 to audio range. Oh, and this should not be static. This should be like an actual member function. I think this should be like a few basic ones. We can do triangle. Hopefully this should be okay for now. Let's see if we got this correct. So the idea is, here in my synth, I'm going to include oscillator. Let's start with the fixed one. So the fixed one would be oscillator, generators, sine. Let's see if I got this one correct. Oops, this did not work. Let's see why. I have the oscillator. The oscillator calls the correct generator, I think. What did I miss? What did I miss? Am I calling the right thing? Yeah, that's called the right thing. So what did I do wrong? What did I do wrong? Oh, I might need to, no, I think I did this incorrect. I think I might need to think about my math here. Be assuming too much about this, right? Yeah, I think if I might not. I think this is. I need to move this actually into the sine only. I think, right? Huh. Hey Lior, I'm really glad you liked my recommendation about the algorithm. They're a great band. I wish I could play them on stream. They're such a great band for programming. Yeah, I think I'm looking at the way I've done it before. I think I might just need to have the phase be linearly set. Yeah, I think I might just need to move the yeah, because maybe I just need to do this. Yeah, is this how I did this? How did I make it work? Let's see. Oh no, there's no header. Okay, so I think I still need that to move the phase. Right? just looking at some other code that I have here in the side. Yeah, because I probably know this. I just need to do the time per sample. Right. Yes, and then so I just need the time per sample and then multiply by pitch. So I think it just needs this to actually be. This needs to be this times the pitch. I think this will be more correct. And then in the specifically in the sine wave, right? In the sine wave, I need to do the that little calculation there because I don't need it in the saw. That makes no sense. So I need in the sine oscillator. This needs to be yes. So right. So this needs to be multiplied by the 2 pi thingy. I think it will be more correct. And then I think I need the same thing. If I understand right, do I need the same thing with the square, or can I just assume? Can I just ignore this and just say, well, yeah, I might be able to just ignore the sine thing for the square, right? Just do a plain square. I should be able to just ignore this. Let's see if I can do this. All right. This envelope is a little choppy. Let's make the envelope have a little bit more release. Where's my voice class? Slightly more release here. But I think this was a good sign. And I can actually just make a change here so that it'll have good, beautiful sine wave. And then let's try one of the other ones. Let's first compile this with square. Good. Good. And I think now my saw should actually should be better too. I don't think I think whatever I did there before was just some bad copy and pasting. Okay. Beautiful. Good. And now, when I look at this, I can actually, I can probably use a different, because those actual generators, they're actually fixed. Like there's no stateful except for the white noise, I guess. I probably, yeah, I can probably just pass in different ones at runtime. Like I think this, instead of templating this whole oscillator, I probably don't need to do this, and I don't even need to do that. I can just say, when you process this, type name generator, and I'm gonna give it the generator. Right, and then here, blah, blah, blah. Oh, same with this function. It's this little helper. This also needs the generator. So I can just pass in one whenever I'm calling this. I should be able to pass different ones because the phaser would actually be reset. Because the phaser would actually be reset regardless of what generator is used. Like let's say I want to change the pitch or do that. The phaser takes care of that externally from the oscillator. So this is really good. And then I'm just going to call this with the generator. Yeah, and I can probably make for example, the sample rate stateful, like so that there's a prepare call instead of passing it every time. I guess that's one way to do this, right? I can make two separate calls. Because the pitch isn't, but I think this is okay. Even though there are some minor optimizations that can be done to this process, I guess. Right, because I have the oscillator. The oscillator is generated. Now the synth, for example. Now this is not a template; it's just a regular oscillator. And the good thing is, now we're just going to talk about how can I can actually have a fixed list of oscillators, of generators here. So I should be able to do something like for example, I'm going to do a stood array. Would array be good here? No, I can't make an array. They're not the same type. So I'll need something like I could just let me do something here. Something basic like oscillator list or something. These would have white noise. Doesn't even need this micro. This should actually be the generators. White noise and the generators sine, generators square, generators saw, generators reverse saw. This is just list. This actually, I'm just gonna keep it here for a second, but this should actually probably be static because unless, there's no state here, except for the one noise, but I don't care about it. So there should be any problem to share this. So I can do something like a static oscillator list, oscillators. OSCs. So it's going to be shared with all voices, all instances. I don't even care. There's nothing here to check. The white noise is the only one that I need to make sure that it's actually shared with it's not shared with different instances of the plugin, but I'm going to not care too much about that for now. And then I can actually make a parameter, right? I can make a parameter here from the synth, in the synth, that changes these types of oscillators whenever I want to. So for example, let's do so the way I usually like to do this is that there's usually something called something like a synth shared. Let's call it basic. It's still part of the basic synth shared. I'll just put the oscillator list here. OSCs. But I'll also do something like a parameter here, or something like int selected OSC, or let's even I can do like an enum class OSC option, basic synth OSC options. This is starting to require its own namespace. Sine, square, saw, reversed, saw, white noise, something like that. And selected OSC equals options sine. Let's make this the default. And then this would be shared with all the voices. And all the voices, when they process, they can just access this. So then, but we should probably do the same thing with the ADSR parameters, by the way, instead of making this per voice, because we probably want to control that as well. So while I'm here, I'm going to grab this and do something like JUCE ADSR parameters, ADSR, because those are all also shared with all the voices. Let's initialize them. There's good values that I like. Awesome. I'm going to remove all this stuff from the voice. And instead, now when I'm processing this, first of all, in every process block, what I'm going to do is, whenever I'm starting the note, I'm going to also do set parameters from the shared ADSR. That's going to be the shared parameters for all these. So now the synth can kind of pass that on. And here, I'm going to have a helper function that says something like here I'm going to need something interesting. Here I'm going to need, how am I going to do this in a return value? Let me think about this. Because it's going to be so simple to just make a base class for the oscillators, but I really don't want to. I want to avoid that by any means necessary. Let me think. Because the problem is, because of the way I've done this, those could actually be multiple types. And I want to pass this at runtime. So one way is I can use, perhaps that's a good option, I can use a std variant here. A variant could work. Let me think about this. Might rethink this interface here. Because if I'm oh, you know what? I know how to do this. This is going to be fun. Instead of what I'm going to do is I'm actually going to make this a generator on its own that calls another generator. This is going to be fun. Okay, where's my oscillator list? Good. So the oscillator list is itself would be something that's compatible with a template generator. So that means it can do float get y with a float x. That's basically it. And yeah, in fact, it could have, oh, this is going to be fun. So this one, so this is actually going to be, so it's also going to have the options here. Selected equals basic synth option sign. And this would just do, this would switch. Oh no, that's not good. Actually, it's not good. That switches. No, I don't like it. I had a solution, but it's not gonna perform so well. And no, I need something that gives me the right. I basically need to do something where the actual processing of the oscillator is actually different. Right? Yeah. Yes, so I need to think, how do I switch this? Because this is like a compile time thing that I was trying to express here. Let's see what would be the best way to do this. Yes. Let me think. Probably overthinking this, but I can generate new oscillators with all the options. That's one thing. Yeah, maybe it's less of an issue than what I'm thinking. Probably what I need to do is I'll just for brevity here, I will set these separately. So let's do something like let's do something like void set pitch float frac float SR. going to separate these two. So I might combine these if I need to. But this would allow me to not do this. Kind of assume that the pitch has already been set. And then process. Yes, I think this would make it better. So that what it means is, once I have the list, all right. Yes, I can actually process this with like void process, and I can pass in the oscillator OSC. Buffer. And then I can do something like switch on the selected. Or I don't need to make this function here. I can do this from here. So let's keep the list not stateful. And here in my basic synth voice, I can do first of all, I can do oscillator set pitch with these little things. I'll probably make like I'll just give it a little bit of helpers here. So void set pitch, JUCE MP note, double SR, just so that we can not avoid these conversions. And this would call set pitch with note, frequency in hertz, float SR. These, and then this would just get the get note, and then we get sample rate on the voice side. And then when we process this, we'll need to switch on the shared selected OSC selected, and then depends on the different ones. This would call either OSC process, two OSCs, shared OSCs. We're going to use this a million times. OSCs, it's going to process with OSCs, sine. Buffer. And we need this little kind of verbal switch, because this would compile to really efficient code. So that's really what it's there for. So square, saw, reverse saw, noise. And then I don't need this anymore. So this means that I'm just going to add up a parameter here very quickly, and this parameter would let me just control this at runtime. So now that I've done these, I have everything here. This looks good. This doesn't do much. Like there's a default constructor here. It does nothing basically. This is not needed. We already share the ADSR. That's good. We could probably now expose the ADSR stuff on the interface. So now, why did we do all of this? Because now from our plugin, I can create a parameter. So the parameter would be something like I need to store it, so I'm gonna need to do something like a JUCE audio parameter choice. Let's call it oscillator. I can just create it right here. So equals new. It's gonna be pretty wordy. Audio parameter choice. And this takes the parameter ID, which is OSC1. Name is OSC. Now we need a selection. So it's sine. Hope I did this in the correct order. So sine. No, since sine square saw reversed saw noise, and the default is 0. So this is my beautiful parameter. I can add it. So add parameter oscillator, and then when I'm processing it, before I'm processing this, I'm gonna do something like synth. I also need this little thing. So now I also have the synth, but I also have the basic synth shared. And then I should be able to first of all, in the beginning, after I set up, I can do 402 voice synth voices and do voice shared equal pointer to. I can also do this in a constructor, but I'm lazy. And then in a constructor of the synth itself, and then I can do shared voice C's selected equals a cast to the basic OSC options of the oscillator get index. So just going to cast it into that enum type, and now when processing, this should all be set. Right? I don't need to pass it. It's already passed. You have the pointer to it. Let's see if I got it to work. If I missed something. But what I should get now is an oscillator that's changeable at runtime. So hopefully you can hear this. It's a bit louder. Okay. Square, saw, reverse saw. Kind of sound the same. And then noise. And I should be able to change it while I'm holding a chord too. So I can hold the chord, the switch, beautiful, right? Kind of fun. I have different oscillators. This is a good start. There's still a lot to do. I probably need to move this into a table. Let's go over the code, see that I made some sense for myself. First of all, I have the phaser class. Phaser class is super basic. It just moves the phase according to pitch, and then fmods it so that it basically modules around 1. So it's a super class. The oscillator class is calling that but basically it sets the pitch, and then it just for loops over a specific over the sample with a specific generator, and then it copies it there. Let's make these two functions be right next to each other. That makes sense. Reset should actually be more related to set pitch. So pitch functions and then process functions. Process functions loop just eventually calls this. So it loops over the samples on a single channel, single mono channel, and calls a generator. And this is a template, so that's how we could do the different ways to do these, like sine, square options, right? We could just ask for the phase and then draw the shape based on the phase. And next step might be to make this, instead of calculating, actually calling the math at runtime, we probably can, especially when we're going to have multiple oscillators stuff, we can probably make it into a table, so we can cache these operations and then interpolate them. But this is like a very basic way to do things that, generally speaking, should work. Let's, just to clean it up before I commit this, let me create a CVP file for most of these functions. So oscillator. Let's add this thing to the build. So basic synth oscillator.cvp. Hopefully help to clean up this interface a little bit here. And all these generators, I might move to its own thing. Like these are kind of, it's their own separate world. So generators. Could have now even started to think what it would mean to make these, these templated or support double or something like that. Yeah, so there's examples here for basic ones that are stateless, but also one that is stateful, which is random, because random, we can even initialize this with a seed. It's also another way so we can have like consistent noise if you wanted to do that. Yeah, because Windows basically ignores the phase and just does whatever it wants. Another way I could think about doing this is I can also I think about doing this is also I can decide if a generator is like the generator itself can decide if it uses a table or not. So like I could do like instead of doing a generators saw, I can do a generators table saw, and that would be like that's how I can maybe compare the same math with either real-time math or a table that we're interpolating over. That's how that actually might be a good way to compare things and compare the audio of it if we go deeper into this. What else? Not predefined. What did I do? What did I do? I forgot to close the namespace. Let's see if we're good. Okay, let's play. Sine, square, saw, reverse saw, noise. Not bad, not bad. I think it's good work. Let's commit this, see where we're going, and so added multiple oscillators to the basic synth, as well as a templated way to switch generators. All right, that's not bad. Some more coffee. How's everyone doing today? I know it's pretty early. This is not even 9 a.m. here. But I'm enjoying this project, so I'm going to be continuing to do that until we're actually getting close to a game of sorts. This eventually is going to be a game, I believe. Hopefully it's not too far from being gamey, but yeah. So I think, you know, I'm gonna not move too forward with the oscillator here. The only thing I might want to do, maybe I'll put filter and volume. I don't know. Doesn't matter all that much. I think I can work with this. I'll do slight changes so that it's more self-contained. Let's do those changes right now. So there's a few things that I put in my processor that I probably want to move to the synth, just for cleanup. So this whole shared stuff, what I'm going to do in the synth here, instead of making it MPE synth of these. Okay, so what I'm going to do, I'm going to make, yeah, so what I'm going to do is I'm going to inherit from this instead of using, I'm going to make it its own struct. And then what I'll do is I am going to have another similar function here, because I need to do some things before the process function. So I'm going to do something like process synth, let's call it, and I'll need a constructor. Process synth. You know what? I don't even need process synth. This might be even too. I don't even need that for now. I just need the constructor so that my plugin would actually take all these shared but I do need the basic synth shared here. I would need to go through the voices and give them the shared objects in the beginning. And that's pretty much it. That's pretty much all I need to do for the initialization. And then I can, in my plugin processor, I don't need to have the shared object anymore. It's a part of the synth. I can just do synth.shared. Because the other voices already have the parameters to this, so I can just set it. I can also use that opportunity to set the envelope parameters if I really want to do that. Yeah, I think that's okay. Yeah, I think this is not bad. I do want to do one thing, which is that I want the basic synth to have another namespace. This white noise now is not in use anymore. Right? Yeah, basically, Yeah, I can just remove this white noise class. If I want to, I can just use, I guess, the oscillator with white noise. So I can just remove this. It's not needed. Let's call it audio basic synth. And then just change the names here. So oscillator list. OSC options. OSC options. Here I can just call it basic synth voice. Voice synth. Okay. This is a little bit more expressive. Then when I call it from here, it's just going to be like basic synth. Synth. This would be basic synth OSC options. This is going to be a bit more clear and lead to less naming collisions. All the normals. You change the selection based on this. We process. That's it. Like the actual main plugin here doesn't do much. It's relatively clean. Let's move this to CP file. I want to. This stuff is in my library, so I want to make as little things exposed as I can. This reverse stuff, by the way, might not be that useful for playback, but it is going to be useful if we have modulators. So that's why I made this. Yeah, so this is an example of how to structure this thing. What else did I want to make sure that I know how to do here? So different processing runs on the switch based on the type. That's good. Probably can also do something like the other way around, like instead of doing all these, because this whole thing, as you can notice, is completely stateless. And so I could just make it like, for example, make all these functions so that I call these and pass a generator and a phaser, for example. That's another way to look at this problem. Should be the same idea. Okay. Maybe have some spaces here for clarity. Okay, apply gain. This should probably be exposed just because we need a volume control of sorts. I might just remove this from the voice from now and then just put a volume control on the main plugin. It might be nicer. So something like JUCE audio parameter float volume. This will probably be in dB, but I'm going to be I'm going to start by just putting it as a number, but then I'll switch to dB later. So this would be equals new audio parameter. Okay, this is just annoying. Let's start by going to audio common here. Let's use something like using float param equals JUCE audio parameter float. Choice param is choice, bool param is bool. Int param is int. Those are really annoying to type twice anyway. I will probably need to adjust that pretty shortly. The JUCE syntax is not that ergonomic here. So float param. And this would just be choice param. New choice param. Slightly more ergonomic, I guess. New float param, which would take volume 1 and then volume, and this would take something like a range. Oh, I think I just do minimum maximum, right? So minimum maximum would be this probably shouldn't go to 1 just because it's going to be super loud with the synth. Let's do 5, and then the default is going to be something like that. This is going to be completely boring, but just to get some control at parameter volume here, and then once we finish, let's just do the synth process. Buffer, apply gain, volume kept, right? It should give me the actual volume here. I think that's good. Good, volume appeared. You can see that it's very choppy. We'll fix that in a second to avoid the zipper noise. Good, so that works. Let's commit this. Refactored basic synth to hold its own shared state and edit volume control. Now let's quickly improve this volume control, because volume is important. So let's make something that's more composable. I'm gonna call this smooth gain. It's gonna be one of the more useful things. It's just gonna wrap a JUCE class that already exists just in the interface that I think is more composable. Smooth gain. CP. So the actual way this is going to look, this is going to be a prepare call, double SR. This thing internally is going to use a JUCE smooth value float, smoother, and there's going to be a process here that says buffer. Float gain. And this is going to be smoother set target value gain, and then smoother apply gain buffer samples. And this actually already does what it should be doing, so I don't need to do much. It's just about the interface of creating this and calling this, and there's a couple of other things that I need to add on top of it. The one thing that smoother set reset SR, and let's do something like that. That should be hopefully a good time, like 10 milliseconds. I know. 5 milliseconds. I don't know what's a good time. Let's start with that. Is that float? Double. It's double. So let's do this, and then double time equals this default. The one other thing we need to do here accept, and a little thing I probably do is bool first time equals true. So whenever we're preparing this, I should kind of remove the smoothing so it would jump. This is actually very important for a synth. We would need yeah, so whenever I'm preparing this, or let's call this, let's do something like a disable smoothing. So this would be so that if I'm, or let's call it should smooth equals false. The reason is, if we should smooth, we should do this, but otherwise we should do smoother set current and target value. So this is something that the JUCE smoother doesn't do. I want that whenever we're preparing or whenever we're resetting the voice or something like that. That means that the next run would not smooth. It would go directly to the value. This is super important, actually. So we need that something like this. It would be something like should smooth equals false. So only to the first run is not going to do any smoothing. Never. We have to reach our initial value. This next run, and we can also do something like void. Let's call it something like how am I going to call this? Yeah, because I should be able to do something like set value now. Float value, that's another option. And this would just do this. And this can actually work like this, right? So if we're setting, only if we do this, then we're like next runs we're okay with smoothing, but only for this first time we need to force that. So resetting should smooth false, which means next time, whatever next game you're going to get, I want to say hello to Bizal. Am I reading this correctly? Bisal. Hello, thank you for joining my stream. Yeah, so these should be, I think, the basics of the volume smoother. This is probably going to be one of the more important building blocks that I have. I probably would pretty soon refactor this whole smoother into something else, because this logic actually happens all the time. like this kind of logic where the first prepare, disable smoothing, and then we're smoothing everywhere after. Like it's very important for this to work like this. In voices or set value now, or we can just do I think this would be okay. Right? I can also just like, disable next smoothing. Which will just do this. So this can be called from a voice. So I'm doing this because now, first of all, now it should be easier for me to just let's go to my plugin processor, and instead of here I can just do something like a smooth gain. Gain, like most processors, gain is to be prepared. So prepare with the sample rate like this, and then instead of doing buffer apply gain, I should be able to do gain process buffer volume get. So it's pretty ergonomic and should hopefully be good enough. Let's take a look. Look at this beautiful smooth volume. Hey, I hear a couple of clicks in there. What are those clicks? I think I might have a bug in my oscillator. Switch to another waveform. Okay, that's clean. So my sign is clicking. Let's see why. So let's fix that. First of all, let's edit smooth gain, wrap around the JUCE smooth value with additional logic. Reset logic. So that's good. Now I need to look at why my sine wave is clicking. Let me screw that up. Send oscillator. What to do here? Phaser. Okay. Look at the generator itself. Did I do something weird there? Thank you, Leo. I'm glad you enjoyed it. Have a good night. It's pretty late where some people are. Well, it's very early here. I'm gonna pretty soon go back to some other projects that I need to work on. Maybe even get some food. I don't know. Do I get food? Do I eat? Do I not eat? So many things to think about. Okay. I wonder what's wrong with my thing. I may have like an off by 1 error. Oh, the range of this might be off, right? I might did this to map this to -1 and 1. Like this might be 0 to 1, and that's why it might be probably clicking. First of all, this is a bug. This is not 0 and 1. This should be -1. So this is a mistake first. Right, this should be something like do something equal. Right, I think the range of values this would give me would be assigned between 0 and 1, so I would need to return this. Like sine wave or sine val, something sine val. So the problem, like it might be in the wrong range. I could probably visualize this, see if this is correct. Good. Now I have a click on the star, but this is more correct. Let's see. Okay, it's backward bear. Good. We should probably put this as a plugin and see that this looks kind of correct. So I can build a plugin version of this. So let's add VST3 here. Let's build a VST3 version of my game. It's going to be so much fun running this game as a plugin, by the way. You'll see when we start getting into the sequencer, which is next step here. Okay, let's run my beautiful plugin. Let's open Cubase. Cubase will not take down my entire stream. I'll need a synth track here, and it should show up. I should have my rhythm game show up as a synthesizer, immediately making really horrible noise. We should figure out why. Why did it make this horrible noise? Whoa, some funky things are happening. Why is it doing that? Is something else running here? Whoa, this was very creepy. Which sample rate am I running on here? 88, switch to 44 something. Whoa, something that's really weird is happening now. Yeah, I probably should apply gain on the voice level. But anyway, let's this might be a problem with the different sampling rates, so we need to see that in a second. Anyway, yeah, why am I recording MIDI? Let's can I have a visualizer here? There should be something like that, right? Like an analyzer. There should be an analyzer here that does that's good. Okay. Can I get a better way to look at this? Maybe? Let's just record this and see what this looks like on the result wave for now, before I do something more bulletproofy. So I'm just going to record a few notes. Okay, so let's record all these, and then let's just do something like render in place. Let's take a look. Okay, so this is definitely not what I'm expecting to see here. Oh, I might need something like a way lower waveform just to actually see it, right? But I think I'm getting something very unclean here. What does this sound? Oh, I just recorded the noise. I forgot that it's not. I need to record the audio directly. So let's start. Let's do sine. I could probably automate this, right? Let's do. Should take some automation. So I should be able to record this automation, right? Like the writing, and then okay, so I just automated it, and then I should be able to render in place with that automation, those automation settings. Okay, this is better. Okay, here you go. So this is my pure sine wave, which does not look like it's actually correctly mapped to level. So there's like a DC offset here. I need to fix that. This is my square wave. Interesting. So it definitely does not look good. I need to work on my math here. My waveform math is not perfect. Sounds cool, but this does not look like a clean thing. Saw. There's something a bit jumpy here. I wonder why is it so jumpy. So yeah, so I definitely need to work on my own little logic there. Probably need to look at the numbers that I'm getting in the interpolator. So I need to look at my range of values to fix this. Okay. let's do some things to see what I need to abstract this correctly. For this, what could be good is work with the console app. That's probably why I made this console app. Let's remove this little folder in here. It's completely unneeded. Let's make sure that it just goes to main CPP. So getting to score, I am going to bring in EA audio common. H. See set pitch. This is also auto generator gen equals the audio generators. Let's do using namespace audio. So I have the oscillator here. I have generators saw. And then let's set pitch. 1 hertz. Sample rate of, let's say, 44. 100. And then let's do I should just do it. So I should be able to do something like auto vec equals to vector float with just vector float vec resize to let's do 1000 with 0. Doesn't matter so much for the value, I guess. And then let's process vec data. So it's generator, vec data, vec size. Simple vec dpg, simple, something like that. Oh, here we go. I need to fix this. So this does not. I needed to write this little abstraction correctly to work correctly in a standalone plugin situation. So my library was still not tested correctly, if defined properly. Okay, here we go. Goes up. Okay, so let's make this much faster. So that will let's try 400 hertz or something. Let's try 4000 hertz. Okay, good. So I'm expecting this to go up 0.8, 0.6, 0.4, 0.2, 0.4, 6, 8, then go back 0.8, 0.6, 0.4, 0.2, keep going up. This looks pretty correct, right? reopen this. Keep going up towards 1. Minus something, right? It's pretty fast, but so should. Yeah, I mean this math here does look pretty correct. This is basically what I was expecting to see here. So why was when I was looking at Cubase, is Cubase still open? It looked a little bit off. It looked off. Like let's try something with a sine. Same thing. Okay, I can already see that the range of values is off for this sine. That's for sure. Yeah, -2 or something. So that's not good. So the problem is my generator with stewed sine of this times the phase. This might have not provided exactly the range of values that I thought. Like I thought this is going to be 0 to 1, but I guess it's not. Yeah, this can provide something negative. So let's GPT this. Let's ask GPT. In C++, I have the following function to calculate a sine wave. X is a phase, between 0 and 1. What should the range of values be? Okay, so it's already -1. I don't need to do this extra thing, right? Okay, so I just added this extra calculation for nothing. I can just return this as is, right? So why did I hear clicking when I did that? Let's see if I get the clicking in my standalone as well. It's not clicking now. That sounds good. I don't know what, maybe it's just some. Yeah, it's not clicking. I have no idea what. Maybe it was just like some momentary thing that I heard. It had nothing to do with my math. Let's go back to the VST3 version. Those little jumps I saw might have just been because the frequency was too high. Let's take a look. You know what? I should actually be loading this in Plugin Doctor. Do I have Plugin Doctor installed? I should. Okay. Plugin Doctor. Let's load my rhythm game. It's not here. It's in the user VST3. Oh, it's only just for effect buttons. Okay, so this doesn't work. Let's do it. Let's load it in the dock. Close Cubase, reopen Cubase. hear that? There's super weird noise coming out of one of the channels. I have no idea why. Maybe the problem is I just need to clear the buffer at the beginning, which I don't do. So maybe it's yeah, maybe I probably need to do that. So let's do something here right on the top of my yeah, like I probably need to select a buffer and clear, because otherwise I might be passing junk the DAW is giving me, and it's kind of expecting me to clear that buffer. And I should probably do this after the normal bit. Go back to Cubase. Hopefully this is clear up. Do not have that crap that I had there before. Okay, no crap. Can I play now? Okay, it's not clicking now. I have no idea what it's wrong. Okay, let's record a couple of notes. 2 notes. Place. Let's take a look. Okay, this looks like a beautiful sine wave. Look at this beauty. So beautiful. Beautiful sine wave. Okay, this sine wave is doing great. I am happy. Okay, so this is good. Now let's see the other ones. Let's try square wave. Ah, look at this. Beautiful. Beautiful square wave. Love this jump here. It's funny because I'm not reporting any jump. Like I'm literally either doing above or below. I wonder why it's this. It's probably just a visualization. I don't know, because my lines are supposed to either provide, like on a sample by sample basis, needs to provide either either the high value or the low value. I wonder why the smoothing here happens. Interesting. Okay, let's try the saw. Yeah, clean and beautiful. Okay, this looks great. Maybe my problem was with different sample rates, so maybe that was what's screwing this up. I wonder if this is just a visualization thing. This little thing, like why would that happen? Interesting. I don't know even how those values could even be reported by my generator. My generator should be pretty even if there's a jump, the jump should be to one of those values immediately. Interesting. So that's I'm gonna count this as a visualization on the QA side before I assume any further. This is better. Let's try a different sample rate. It's possible I'm not handling different sample rates correctly. This is good. Sure. So let's record this. Okay. And then render in place. Yeah, this looks awesome. I'm not sure what went wrong in this previous one. It was just, who knows? It was just probably off with my synth as a whole. So I think we're looking good. Good. So I've fixed generator math and scaling. Okay, I think we're good with on that part, on the synth part. It's very basic. I probably need to have a sampler or two to make drum sounds, but let's wait with that. yeah, okay, so I think I'm going to take a break. I've been streaming this for 2 hours. Might need to go to work on some other projects, and I'll come back to the stream, do another stream a bit later. Thank you all for watching, and